going to, hi, hello, and then we're going to do something special and cool, okay? So, what have we learned so far today, okay? Can anyone tell me? Or even yesterday, what have we learned, Joe?
Today we learned about accuracy and different measures of how, like how to describe a model and it's good.
Very good, yes.
We're going back to yesterday as well. We talked about the different kinds of models, regression versus classification, and talked about some examples of each.
Yes, exactly. So regression, classification, model evaluation, how we can improve models. Okay, that's all kind of been focused under the umbrella of supervised learning. Okay, and one other thing that I would add that's not necessarily under the umbrella of supervised learning, but is also important, is that the CIS sandbox and Bentley has a very nice snack budget. Okay.
We hope we do.
It was great. If I had to answer the question about lectures or snacks, 100% snacks. Okay. And of course that's only for my own lectures. Their lectures are, yeah. But anyway, now that we've kind of thoroughly explored supervised learning a little bit, okay, we're ready to talk a bit more about other types of machine learning. So if you remember, Professor Leo, at the beginning of yesterday, she mentioned that there are at least three, in fact, there are a lot more, but there are at least three different types of machine learning. That being supervised learning, unsupervised learning, and then reinforcement learning, okay? And so across all these different methods in machine learning, essentially, you can do a lot, okay? And so now that we've explored supervised learning, we're going to take a little sneak peek at unsupervised learning first. So to introduce unsupervised learning, let's kind of recap quickly what the principle behind supervised learning is, right? So supervised learning is essentially when you effectively tell your models that these are the answers, okay? And these are kind of the labels that you have for your features, for your input data set, and figure out like the relationship between the input and the output. So that could be, you know, this parameter, and this parameter leads to this classification. It could be there's this parabolic relationship, or this parabolic regression that is related to, you know, whatever our data set is. It could be this split, as you can see here. The clicker doesn't show up on screens, but it could be this split between, you know, the age and then the tumor size, in predicting whether or not this tumor is benign or malignant. It could be whatever, as long as you already labeled your data set, right? So you have that study guide, you have that answer key when you're studying for the test. Unsupervised learning, as this name suggests, is when you don't have that answer key and you have to kind of infer your own answers, or you have to create your own labels, okay? Sometimes you end up with problems that don't necessarily fit into very nice labels, and sometimes you don't end up with problems that are very easy to predict. You may not know what shape your data will take on until you process it, and so that's why we kind of bring in unsupervised learning into the mix. So unsupervised learning deals with unlabeled data. That's what you want to write down if you're writing stuff down, or type it down, okay? Unsupervised learning deals with unlabeled data, okay? And as you can see on the right here, you can see there's no like circle versus X. They're all triangles, and we're trying to figure out, you know, what is the relationship here? What can we label here, okay? And so there are a variety of different ways of doing unsupervised learning, for example, clustering and dimensionality reduction, as we've seen here. But for now, we're just going to focus on clustering because it's a bit more simple. Dimensionality reduction requires a lot of linear algebra and math that, frankly, is very, very, even I don't fully understand it because linear algebra is challenging. And it's a second semester course. So anyway, let's talk about clustering first. So clustering can be kind of demonstrated with this cute example here, okay? So a panda has given birth to twins. How many people like pandas, right? Pandas, great, great. Not the library, not the pandas library. I hate that too, okay? But like the animal, the panda, okay? And it was a complete coincidence that we happened to pick pandas and like the library's named pandas. But what do all of these news articles about this panda singular tell us, aside from the fact that, you know, people love pandas, right? So take a look at, you know, how these search results or search threads are grouped up. What is it? So what does someone notice? Anyone, feel free, just shout out an answer. A lot of them are about twins. Yes, a lot of them are about twins. Actually, I think all of them are about twins. Yes,
They all have to do with like Tokyo or Japan.
they also do with Tokyo and or Japan.
They're all posted by different news sites.
They're all posted by different news sites. Yes,
They're all in the same, like, 16 hours is like the farthest, or all from the same day.
they're within one, more or less 1 day period, right? So they're very similar in time, similar in topic, similar in, I mean, location, because they're all talking about like a Japanese or a Tokyo not penguin, panda, right? Penguins are not pandas. But they're all very, very similar, right? And so when you Google something, you return these similar results. You return articles that are considered very similar to each other. And similar even to your query as well. Okay. And so this is kind of the idea behind clustering. You have a certain amount of data points. So you have a data selection space, as Nate mentioned. And then you're going to group a bunch of them together based on their similarity with one another. So you need kind of a way to measure this similarity called a similarity metric. And so news is an example where it's kind of difficult to do supervised learning because you don't know what you're given. And you need to rely on the similarity between news articles instead. So if someone searches for panda, then you kind of cluster everything together and then you find the cluster labeled panda and you return that. So that's in this case, right? Another example, if I can press the right button, another example is this here. So grouping customers, right? Can anyone point out one group of customers on their TV screens? Right, this bottom, doesn't show up. Okay, the bottom group, yeah, everyone knows what the bottom group is, right? The bottom like 5 people that are pretty much at the middle of the x-axis. Any other groups? Simply, there's one on the right, there's one on the right here. There's one here, and then this guy's an outlier, right? They're like I really have a lot of money, but I don't have fashion sense or something, right? No offense to that person, I don't know who they are. But the clusters are essentially represented by something like this, right? And we can see that there are approximately, there are 4 groups here, okay? And this number 4, it might be different if we said, let's group them into 6 groups instead. So let's say if we wanted to group them into 6 groups or 3 groups or something other than 4, the groups might come out differently, right? And so this, if we want to group them into K clusters, this K becomes what? What does it become? So if we said, let's group our data set into K customers, this K could range anywhere between like 0 and actually 1 and like 500,000. What does this K represent? There's one word for it. Anyone? All right, one clue. What is it when someone's on a sugar high? For example, if I ate all of these cookies, what would I be considered? An adjective. Eight?
Hyper.
What do we
Right,
talk
that-
about, which is hyper?
Hungry.
Okay. That's also true. I would, yes. But after I eat the cookies, then I'm hyper, right? So it's a hyper. Exactly. So that this K is another hyperparameter. Okay. And the K is important because it's something called K-means clustering. That's the unsupervised learning algorithm we're going to talk about. This algorithm relies on the natural similarities between subsections of the data. So for example, all of the people on the left in that one group, or all of the people on the bottom. Okay, so for example, here you can see that we're once again plotting comfort versus fashion of shoes. Okay, so you're analyzing people's responses in regards to like Crocs, slippers, Jordans, Skechers, I don't know, all sorts of different sneakers. And you find that a lot of people respond very similarly, right? So, for example, this could indicate that, you know, all of these green dots are probably not stickers, sneakers, right? Because they're very, very comfortable, but they're kind of average on the fashion scale. And in comparison, these could be more like high heels because they're not very comfortable, okay? And they're very fashionable. Or maybe, I'm not very fashionable myself, but, you know. So, sorry.
You look great in high.
I wouldn't be able to walk either. So clusters can tell us kind of about the specifics of relationships of data, right? Even if your data is unlabeled. This, by the way, this is where the previous presenter put Jordans, and I just don't agree with that because as you can see, I'm wearing Jordans right now. So I just skipped that part of the lecture. Sorry about that. If you agree with them, I'm gonna reserve my comment for outside of class. Anyway, this begs the question, right? How do we find these clusters or these relationships between the data? So I don't know, how can we do that? We have unlabeled data and we need to find clusters. What do we want to do? Unsupervised learning, right? So XACD guy, hi, hello, welcome, glad you could join us. How do we find the clusters? We use this following process, okay? So let's start with all of the unlabeled data sets, okay? We're gonna pick some random k number of clusters. In this case, we'll say 6 because we can see that there are more or less 6 clusters on the screen here, okay? Next, we're gonna randomly pick a series of what are called centroids. These centroids are the, we'll say, center points of each of these clusters. So they're where each cluster will be gathered around. And they can be picked anywhere. They can be picked all in a line up at the top. So everything, it could be like 1, 2, 3, 4, 5, 6. Or it could be along this diagonal, or it could be, you know, 1, 2, 3, 4, 5, 6. Anywhere. You're picking them randomly. Okay. And then after that, you assign each particle or each data point to the centroid that's closest to it. Okay, so let's say we took k equals 6. We place our centroids in these locations. They're represented by the super small colored dots. Okay, can everyone see those? Yes? Good, yes.
How did you decide where to put the centroid?
They're completely random. So it could be different every time you do. Okay, and we're gonna explore that later, but completely random. Okay, so these centroids, the colored dots, and now we're gonna assign each data point to the cluster, or each data point to the centroid that is closest to it. Okay, so the data points have been colored here based on what centroid they're closest to. And so they've been assigned to that centroid. The next step is we're going to move the centroid to the weighted geometric center of the samples assigned to it. Okay, so essentially we're going to take the coordinates, so to speak, of all of these different points, and we're going to move the centroid to the average of, in this case, the x and the y. Sometimes it's 12-dimensional, sometimes it's even more dimensional. But it's the geometric center of all of these points. Okay, so we're going to move them. Hello. Okay, so now they've moved. The centroids have just moved closer to their group. Great, awesome. So now that the centroids themselves have moved, the data points might be closer to a different centroid. Okay, so let's take a look at this graph. So you see these two blue points here. They're actually now closer to the, instead of being closer to the blue cluster, they're closer to this pink cluster's centroid, right? And so, you know, it's hard to tell which one they're closer to. We might even want to reassign the blue ones into the pink cluster. And so we kind of have to keep going. We have to do this step again and again and again. And we keep going until essentially until our centroids stop moving very much. Okay, so we're going to keep going. We're going to reassign them like this. That looks a lot better. Okay, and then we're going to keep going. And more or less now, all of our centroids have stopped moving. Okay, and I'll tell you that because I created the slides. This is basically where our clusters are going to stand. And this is true because we started our centroids in that particular arrangement, okay? So to speak to your question once again, it might be different if we assign the clusters differently. So K-means clustering is something called an indeterminate algorithm, where there's a degree of randomness that's built into the algorithm. And this randomness comes from the initial step of choosing what data points to get the centroids from and where to put the centroids. And so, if we had chosen the clusters to be different, these clusters might be completely different. So the red and the right half of the blue might be in one cluster, or like the aqua clusters at the bottom might be completely split. Okay, you don't know. And so if we ran this again, do we get back the same clusters? Not necessarily, okay? And that's okay. Once again, do we always get back the same clusters, everyone? No. And that's okay. Nick, can you do this? Can you do this for me?
Demonstrate?
No. Get everyone to say no.
All right, everyone, on 3, do we get the same clusters? No.
Thank you very much. Okay, it's absolutely fine though that we don't get the same clusters. Okay, because once again, K-means is an indeterministic algorithm. It has built-in randomness. Okay, so it's completely fine that we don't get the same clusters. I know I'm belaboring this, but it's important. One thing we should do is choose a K or a number of clusters that is more or less, it's good in that it splits up the clusters effectively, but it's not too good in that the clusters aren't very generalizable. Okay, so once again, the problem of overfitting and underfitting. And K, the choosing of K, so to speak, is going to be something like this. It follows this kind of curve. And usually the curve might not look the exact same for every single data set, but it's going to look something like this, where it has this super fast decline at the top and then a much slower decline, an area of diminishing returns, as it were. And your job is generally to find that the what we call the elbow. Okay, so it's where the super fast decline changes into a slower decline. Okay, and if you can find a K that's around that elbow, maybe a little bit past it, that's a good balance of computational, like spending computational power against model effectiveness. Okay, so in this case, it's around K equals 3, right? In other cases, it might be even further. It might be down here, K equals 5, or even K equals 8. We don't know. Okay, so that's an example of unsupervised learning. Does anyone have any questions about that before we really address the elephant in the room? Good? Everyone's good? All right. So unsupervised learning, supervised learning, fine. What other examples of AI are there in the real world? And there's one particular thing I'm thinking of right now that I'm sure you all are as well. Yes.
Generative AI?
Generative AI, more specifically ChatGPT, right? So yeah, we do have to talk about ChatGPT because really it's the most, I would say, pertinent and most proximal form of AI to everyone's life today. You can pretty much open up ChatGPT and ask it a question. You can't search on it. Ask it a question and it'll give you, it's very simple to do that. It's pretty much the same as Google, although its architecture is completely different, but that's a different issue. But it's important to understand what it can do, what it cannot do, more importantly, and how it does it, and also why we have all of these restrictions and why we need to examine the applications more thoroughly. Okay, so for example, let's ask, can it be a lawyer? Okay, and if you know what I'm getting at already, please be quiet because we're gonna, so don't spoil the show for everyone. Okay, so I'll tell you, I asked ChatGPT, can you give me several examples of past court decisions that were ruled in favor of the plaintiff where a client got injured and saved on an airline, okay? And I asked it for this example. And the examples it gave me are, certainly, here are a few examples of past court decisions where plaintiffs sued airlines and were ruled in favor. Receiving compensation for injuries. Great start. It answers my question. and very human-like as well. So I'm like talking to like an intern or something that I've overworked. Okay, but then it goes into, then if you actually read into it, it says Doe versus airline X. Does that sound real? No. Smith versus airline Y. Does that sound real? No. Johnson versus airline Z. Does that, no, none of these are, you read into it, and none of these are actually real. Okay, and you're like, how could this happen? Like, okay, fine, I would have caught this. Okay, but what happens if you don't catch it? Well, sorry.
Your teacher will.
Yes, your teacher will, or actually the court might catch you as well. Okay, so I'm not sure if you guys have heard the story of Stephen A. Schwartz, who's a lawyer. He had a court hearing in Manhattan, and he used ChatGPT to craft, and I quote, a motion full of made-up case law that he said he blamed the fact that he did not comprehend that the chatbot ChatGPT could lead him astray. The article describes the court hearing as cringe-inducing. Nearly 2 hours later, Mr. Schwartz sat slumped, his shoulders drooping, and his head rising barely above the back of it. Okay, anyway. Sorry, Mr. Schwartz, I had to make fun of you a little bit, but the point is that ChatGPT does some very, we'll say, questionable things when it's researching data, okay? Or when it's giving you new data. And this is one of many faults of ChatGPT that exists today. So, yeah, it made the cases up, right? Why exactly did ChatGPT not work? Yes.
And so it made the cases up, it didn't like find like case examples, like online, that were just like practice examples, for instance.
Actually, very interestingly, I asked ChatGPT that question. So the screenshot you saw was from, I think it was July 11, 2023. I asked the same question 3 days later on July 14th, and it gave me correct answers. So it gave me non-made up things that it found through the internet somehow. Okay, so ChatGPT can improve itself, and we're going to talk about that. But the original screen capture and things that Mr. Schwartz put out, sadly, were made up. Okay, and the fact that it makes up citations is kind of a big prevalent issue in using ChatGPT for research as a whole. It just, the citations on ChatGPT is just, it's a very big struggle. Okay, but anyway, why did ChatGPT make these things up, and like how does it work? Okay, let's dig a bit more into this. Okay, so how it works, firstly, it's trained from GPT 3.5, and then it's used. So specifically in training, ChatGPT has a goal of generating new and human-like text for conversations, okay? So within artificial intelligence, there's the bubble of machine learning that we've been in. And within the bubble of machine learning, there's like supervised learning, there's unsupervised learning, and then there's deep learning, okay? So we started in supervised learning, then we moved to unsupervised learning at the beginning of this wrap up, and now we're in deep learning. Okay, so we're kind of touching on all three. And deep learning and reinforcement learning, they're kind of a Venn diagram. There are deep reinforcement learning. There's all sorts of different overlap, but for now, just call it deep learning, okay? And importantly, once again, ChatGPT's goal is to generate new and human-like text for conversation. If anyone ever plans to use ChatGPT, first of all, don't raise your hand because we have professors here. And secondly, on your papers. And secondly, make sure you write down that ChatGPT's goal is to generate new human-like text for conversations, okay? It is not Google, it is not a search engine, it is something that natural language processes, or it's something that generates new human-like text. That's its goal. The goal is not to provide accurate information, okay, even if it does. So when we train ChatGPT, we're training something called a large language model. Okay, and a large language model, that's a trained deep learning model that can understand and generate text pretty much in a human-like fashion. Okay, so that's the goal. That's what we're doing. Notably, these large language models have very, very large counts of parameters. So this is a screen grab we got from a website that posted like pretty much the largest large language models recently. And you can see the parameters are well upwards of like trillions, billions. ChatGPT, which is GPT-3 there, this is a bit outdated because it's GPT-4 now, but ChatGPT 3 is actually not even the biggest. If the Beijing Academy of Artificial Intelligence is to be believed, that 1.75 trillion is more than 1,000 times greater, right? So, take it as you will, but it is absolutely, large language models, the emphasis very much so on large, okay? So these large language models are very much so characterized by their size, okay? And so equally important to get good values for all of those parameters is its large sort of training data size. So current large LLMs, as we've seen on the last slide, they use corpuses or training data sets of trillions, if not more, words. And more importantly, these LLMs are trained as general purpose models that are kind of learning the commonality of human languages. They're learning, what is common among the way humans speak. So like grammar, maybe, syntax, maybe, stuff like that, right? And for such large efforts, it's very hard for, even regular companies and organizations and like labs to be able to do this. Really, only a few very, very large corporations and even governments can be able to do this. And so a lot of times, models are taken from a pre-trained, like a pre-trained template, as we are doing with sklearn, but only, on a much larger scale. They're taken from this pre-trained template, and then they're fine-tuned and specialized into their specific use cases. So actually, ChatGPT and its older sister, InstructGPT, they're both taken from the GPT, or the generative pre-transformer model. Okay, and we'll talk about that in a couple slides, but fine-tuning is a very important thing. And so in a large language model such as GPT-3, this generative pre-transformer, the model more or less takes raw inputs from the text body in just like a simple sequential manner, and it's passed in the form of like a string or like a list of strings, and then it's taken into specific tokens, and then these tokens are analyzed, and that's kind of how it works. We'll go into it again in a bit more depth later, but it's important to consider like what is the maximum token size or token limit or token size, right? And that depends on the tokenizer, that depends on various different things. But depending on how big these tokens are, instead of trying to predict like the next 100 words, it might try and predict the next 1,000 words or the next 10 words even. And it might kind of be led astray. I don't know if you guys have ever done the experiment of like having your phone and just typing like the middle autocorrect button, right? That's kind of similar to this, only it predicts only one word in advance. So very often it makes no sense. Okay, so it would say like, actually, we can do it now. I'm gonna pull up notes and I'm gonna spam this while I do the next section. And then, or maybe I'll have Nate spam it for me. Nate, can you do that? Gotcha. Just spam the middle one, okay? And I'm gonna do this next section, and then after that, we're gonna read this, okay? It's in French. Okay, so we're already off to a bad start. Great. But after our input text body is tokenized, it's going to be converted, like we talked about at the very beginning, into numerical representations. And then ChatGPT is gonna, or GPT-3, GPT-4, whatever, is gonna do its magic. It's gonna learn through something called a neural network, and then it's going to spit out its output. Okay. So this is kind of the loss function of or a graph of the loss function for next token prediction. So notably, you can see that it decreases significantly as parameter size increases, and also as training data size increases. So we can pretty much say that the more parameters we have and the more data we can train it on, the better sort of generative models we can build. Okay. And this is an example of the history of these models, I guess. So this was not always the situation. Sometimes at one point, it was kind of like this. So it was almost as bad as a random guess, okay, until a certain point on various language tasks, say it was around, I think, 10 billion parameters. There's this phase change, kind of. And then kind of algorithmic, I would hesitate to say intuitions or instructions kind of were developed. Like a chain of thought, or like, if you know kind of how addition works, you have intuition behind why certain math problems might work, right? And so once that happened, stuff kind of essentially got better. Okay, and it's its calibration ability or its confidence in the next word began to increase as well. Okay, so for large models, this confidence is highly correlated to the correctness. It's essentially the probability that the next word is predicting, that it thinks the next word is predicting is correct. So like if it was, what if I asked it, what is the tallest mountain in the world? Okay, the first word might be the, and it might be like 90% confident. And then the next word might be answer, and it might be 99% confident. And then the next word might be is, 99%. And then the last word might be like Mount Everest, or Mount and then Everest, right? And that might be a 70%. Or it might say the tallest mountain in the world is mountain. Okay, and that might be even higher because it makes sense. I'm asking it, what is the highest mountain in the world? And it obviously wants to answer some sort of mountain, right? And so this calibration ability for larger models, you'll see it's relatively highly correlated to its correctness. Okay, so in order, given all of this, okay, the training of ChatGPT or the training of GPT can be kind of characterized by the word known as you can see on the screen, self-supervised learning. Okay, and once again, we're doing next token prediction. I just remembered, I need to read my next token prediction. Okay, so, oh wow. So I'm gonna skip the French part, or maybe I can translate it on the fly. I, like the English for I, is too good, but there is, okay, that's too hard. Okay. So skipping from the French section, it says combat training with you at your time of duty on Friday with an old man on an app like he doesn't like him or is anything about me getting on there. So that means you need help at work tomorrow, but it's all right after we've done nothing wrong about you guys this week. If it's the time that would have happened there, but that wasn't me, that would take that much to him. So that makes no sense, right? It's still better than the spam emails, but it makes no sense. Okay. So this next token prediction where we only look at one word, it's not great. But if we're going to predict like 100 or 1,000 words, then it might get a bit better. Okay. So when ChatGPT trains, its task is always to predict from the past. So it builds upon its clear idea of what it thinks language is. And human language is really abundant, okay, especially because we have the internet and we have a lot of things that are accessible today. Okay, so there are textbooks, there is Wikipedia, there are journal articles, there are all sorts of news articles, news websites, whatever, okay? And it can essentially grab from an almost unlimited text body. So it's theoretically going to be very, very large training data sets, which means theoretically it should be very, very confident in what it's predicting, right? So when we give it a text input, okay, it's going to spit out a series of probabilities that look something like this, okay? And it should be very, very confident in what it's predicting. So for example, you can see this one, it has a probability of 0.9 or 90%, okay? This is why ChatGPT might generate different answers at different times, or might say something slightly similar but different at different times. It's because it's generating based on probabilities, and it's generating based on what it thinks is the best word to put, given, you know, the past like 30 words or how many ever words it generated, okay? It is once again meant to mimic human language and not meant to give you accurate information, even if it can do that, okay? So the accurate information is generally a side effect based on what it's been trained for. Does that make sense? Okay, so here we have an example. So we start with hi, how. We give it hi, how. That's the first two words. And then GPT might say are. And then it takes hi, how are you? Hi, how are you today? Okay, and that's a sentence. GPT is generated. Hi, how are you today? How is everyone today?
Pretty good.
Good, great to hear. If you're below average, we have cookies, don't worry. Okay, so as you can see, it's already a powerful tool, right? But is it really can we say that this is enough, right? So like if we ask the model this question, what is the highest mountain? it's possible, right, for, like we said, for it to generate multiple different answers. Okay. And they could all be similar, they could all be relatively correct, you could believe them even, okay, like Mr. Short said, you could believe them, and they might even be wrong. So how do we kind of improve it? And how do we make sure that the things that it says are more or less correct most of the time? And the answer is to fine tune it a bit more, okay? When we fine tune, in other words, train ChatGPT itself, the tool from GPT-4 or GPT 3.5, whatever it is, we're going to use something called reinforcement learning from human feedback. Okay, and once again, we're going to post these slides, and also this diagram in particular comes from OpenAI's blog. So the link is down below at the bottom. You can definitely find this somewhere on the website. Okay, and this outlines how ChatGPT is trained, or I guess fine-tuned from GPT. Okay, so yeah, so once it undergoes this fine-tuning, okay, it can say with confidence that the highest mountain is the Himalayas. Okay, and this is a bit expensive because, as you can see, if we go back to the diagram, you can see here in this part particularly, there's a lot of human kind of feedback and human input here. Okay, so even in the first step, a labeler is going to demonstrate what it should say, and then a labeler ranks all of the outputs from best to worst. So like Himalayas could be ranked number 1, or Mount Everest could be ranked number 1, and then K2 ranked number 2, obviously, as an order, and then like Kilimanjaro could be number like 15 or something, right? So it's relatively expensive, and it takes a lot of human labeling, and that's why we can't really call it either supervised or unsupervised learning. That's why we invent this, or not invent. That's why we have this RLHF, reinforcement learning and human feedback term. And really, that's what we use. So yeah, so we build this, we give it that the highest mountain is, in this case, the Himalayas. We label it, and then we build a teacher model so that it can kind of learn that the correct answer is that the highest mountain is Mount Everest, or in the Himalayas, right? And so that part might necessarily be supervised because we already know we're giving it the answer, okay? And then finally, we can kind of do the reinforcement part of this learning, where we take this supervised model that we've trained, this teacher model, so to speak, and then we kind of reinforce it. So either give it a reward or a punishment in a literal sense, or in a literal mathematical sense. And we can kind of go over and over and kind of flog GPT-3 through the simulator, if you will, and have it learn how to become ChatGPT. Okay, so we're gonna give it this this teacher model, and then we're gonna have GPT get a reward or punishment signal over and over. Okay, and so these pre-trained large language models, the GPT, add on to that the fine-tuning. That is what gives you the tool of ChatGPT that you see today. Okay, so now we can talk a bit more about the uses of ChatGPT and what it can do. So remember, ChatGPT, you give it a text input. So for example, like, hi, how do I study for my math test today, or something like that, right? And it'll give you a response saying like, you should stay up for 20 hours straight, chugging Mountain Dew and cramming for, you know, your linear algebra test, which no one should ever do that. Point being, it might not always give you a good response, always verify it, okay? So, point taken. ChatGPT's primary goal is to generate as human-like a text as possible. It is a probabilistic model, so it might not always do that, and it is 100% by no means guaranteed to be correct. That's a bit of an oxymoron, but it is, just importantly, not guaranteed to be correct, okay? So it can provide a good starting point, but you need to verify it, okay? So like I said, it might tell you to study for 20 hours while chugging Mountain Dew and like copying down your paper over and over. The good starting point there is that, like, well, there's nothing in that example that's a good starting point actually, but I guess the good starting point is that you should study and you shouldn't play video games or something like that. But you need to verify that the information it gives you is actually true. Okay, so as much as ChatGPT is an extremely powerful tool, are still warnings we want to give you about it for successful kind of use of it. So yeah, one more time. don't take what it says for granted. Okay, always fact check its information. This is a good principle even for digital citizenship as a whole. But don't take anything like for granted. Always be skeptical, think critically, and kind of don't take what it says, yeah, for granted. Okay, check it. The other thing is that your conversations are kind of part of its learning process. Okay, so ChatGPT can train itself or can fine-tune itself even more from the data that you give it. So let's say like I had 50 conversations with it. All of those might be filtered into the RLHF model or the RLHF training process. Okay, so do be careful about what you give it. Okay, data privacy, once again, these principles apply to digital citizenship as a whole, but even more so for ChatGPT because it's such a novel, like, we don't know what to expect from it type of tool. Okay. And yeah, ChatGPT it's kind of a neutral tool. It's kind of the Promethean fire right now of this age. It really falls on you to ensure that the way you use it is kind of ethical, sanctioned, correct, and that you're using it, yeah, like for good, not for bad, not for bad, right? All of these are relatively common sense, but in the face of ChatGPT being, you know, this completely new, like expectation eliminating kind of tool, we need to kind of revisit these, okay? So great. Now we can actually kind of use it to do something. For example, maybe we want to use it in coding, okay? Can we do that? Do you guys think we can do that?
Yes.
Yes?
From experience.
From experience? Remember, we can't take what it says for granted, and we always need to fact check it, but indeed, we can actually do this, right? So I'm gonna, oh, yep, exactly. I'm gonna exit that, and I'm going to share a chat that I had with it once again in about July or August. Okay, so I'm just gonna quickly pull that up. And now I'm gonna share screen one more time. Okay, so can you write me a script, a Python script to print hello world? Go away, Copilot. Certainly, here's a simple Python script that prints hello world to the console. Print hello, yeah, that's correct, great. To run the script, follow these steps. It even gives you a bonus, how nice, right? Like 2 for 1, buy one, get one free. Okay, you should see the output hello world printed in the console. Great. So it seems like everything works, right? So it seems like it does fine. What if we had it do something harder? Like, for example, build a polynomial regression model, right? So remember, this was the bonus task for the first lab, is to build a polynomial regression. What if we had to do that instead? And so we might try that. So let's go to the next chat, right? So I ask it, can you write me a scikit-learn polynomial regression implementation that I don't really want to read this. You can read it if you want. Okay. The thing to learn from here is that you have to be specific about your questions. That's pretty much all. Okay. So what it says is, and if you want to read this, again, these will be posted. You can, I don't know why you would want to read these, but be my guest. Certainly, here's an implementation of polynomial regression using scikit-learn that includes a cross-feature term. Blah, 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 blah. Great. In this implementation, great, awesome, and it describes itself, okay? Now, it didn't use it, you can see here it made up a data set. First feature, second feature, third feature, fourth feature. It did not use our desired iris data set as we did in the lab example. Okay, so I'm going to say, can you rewrite this code using the iris data set included in sklearn? Please use the first 3 features to predict the 4th feature of petal length. Once again, be specific, okay? Certainly, here's the modified code. Great, it gives you a bunch of code, it describes it once again. When I ran this code, I got the following error. And this is copy-pasted from the console, pretty much, okay? Value error, X has 3 features, but polynomial features is expecting 6 features as input. Please help me debug. Okay, this is where it gets sketchy. Theoretically, ChatGPT is supposed to be able to write you good code that works 100% of the time, right? That's what we think. But evidently it doesn't. And also, when it debugs, it actually doesn't do that perfectly either. So it corrects the code, and the error is still there. It changes a little bit. It says 9 instead of 6, but the error is still there. Okay, and then it says, okay, it goes again, It says, thank you. I thought it worked, okay, because I ran it and it was fine. But it actually just doesn't modify the training data set or add any polynomial features. And I tell it to debug again, and it goes again, okay? And it has the exact same errors the first time. So it wrote the exact same code as it gave me the first time. So we've just gone in a huge circle. And I can tell you from experience that this took me from pretty much 7 p.m. to pretty much 10 p.m. just to get this, okay? To go in one huge circle. So it took me 3 hours to go in a circle and produce nothing. And I can tell you I really enjoyed that evening, okay? That was a time. And I just gave up. I pretty much gave up after this, okay? So evidently, this thing, it's 100% not perfect, okay? Now, if you modify it a little bit, okay, and if you look at the principles behind it, you can see that overall, it more or less does it correctly, okay? It more or less says, like, it more or less does the correct thing. Let's go back up. It has the Irish data set loaded. It does some weird things with like the naming and whatever, but that's fine. And it creates the polynomial features with a degree of 2. And then if you look at the documentation, this parameter is also correct as well. Everything's correct. It just, the model itself didn't work. Okay, and once you debug it, it's fine. But this is a lesson in the fact that we cannot just copy paste the code and don't do your homework at 11:40 p.m. Put it into ChatGPT, read it for 15 minutes, submit it at 11:57, and then hope that it works, right? Because more often than not, especially if it's a hard class, it probably won't. Okay, remember that. Always be careful. Think about think about what you're doing, obviously, but like even more specifically, think about what it's giving you and whether or not that's a good answer. Okay, so I'm going to go back to the slideshow now, if I can. All right, here we go. Okay, so what are our takeaways from all of this? Okay, so how do we make ChatGPT useful? Well, it's a probabilistic language model, right? So I've said this many times. It's a probabilistic language model. It's predicting language. It's not giving you information necessarily. It's just speaking to you. It's practicing English. It's as if it's a super, super smart 7-year-old. Okay, so we need to be able to ask it good, specific questions. And what are really good questions? Well, first of all, once again, it's specific. So as you saw in that example, I was extremely explicit and specific with it, almost to the point of like belaboring it. Okay, so I said, can you give me a polynomial regression model using sklearn with this specific feature, without this specific feature? Okay, telling it pretty much all the parameters to include, telling it what data set to use, telling it how to do that, everything. Okay, so I left little to no room for error, and it still made a mistake. Okay, it's really this is like the reason why I kind of became disenchanted with ChatGPT. This presentation, the process of building this presentation. Okay, and so you have to leave as little room for error as possible, and even still hope that it doesn't make an error. Okay, and that brings us to the second point, which is to treat its suggestions treat its answers as suggestions and not facts. Okay, so it's good at a lot of different things, but it's not great at any one particular thing. Okay, and that's exactly what you don't want in like a college applicant like us three. So it's it faces this niche problem where the more you go into one specific niche, for example, sound processing, or like we see here, polynomial regression, it gets worse and worse and starts making things up. Okay, and so it's important that you can use it as a soundboard perfectly fine. You can think with it, bounce ideas off of it, that works great. But you need to treat what it says like suggestions and not facts. Okay, so in general, treat it like you're talking to another person. If I talk to Nate, however good friends we might be, I'm not gonna take everything he says with 100% certainty. Okay, because I could ask him like, what's the weather today?
Oh, it's raining.
He hasn't been outside for 6 hours. How does he know that? Right? I think you didn't. But like, he hasn't been outside for 6 hours. How does he know that? He doesn't, right? He might have made that up. And in fact, it's actually not raining outside because I just checked. It's like cloudy or something like that. Okay, if it is raining, then I would be embarrassed. But like, okay. Point being, can ChatGPT answer every question? No, not really. It can answer it, but it can't give you a 100% confident, specific, fact-checked answer, okay? And so that's the important thing to keep in mind. It might lack truthfulness, it might make up false information, and sometimes it takes a long time to generate the answers that, that it gives you, okay? So keep all of this in mind, and you will still have a very powerful tool at your disposal. So with that being said, I would like to introduce for the last about half an hour, okay, we're gonna do a little project. I'm gonna ask you guys to kind of envision an application for any of the AI that we've talked about. It could be ChatGPT, could be linear regression, could be anything, okay? And at the end, as soon as you're ready, actually, we're gonna ask you to present to myself, Fee, and Nate, and we're gonna act as your kind of Shark Tank investors, okay? So it's kind of a Shark Tank pitch. Bonus points if you're super entertaining and super funny, and like you pitch it to us as if you actually, as if you actually know, like how to invest and stuff, okay? And so, in order to do this, we're gonna provide you a little demonstration. So let's go ahead and carry that out. So we're gonna pretend that. Yeah. So we're gonna pretend that I am actually. Let me do my code. Okay. You'll see what we're doing. Okay. It's me. Okay. My name is Bentley. I'm currently an undergraduate here at Bentley, and right now my biggest interest, I would say, is AI. And you know why? It's because we attended this really, really great program that inspired my interest in AI. It's called AIBridge. Have you guys heard of it? Yeah.
No.
Well, that's great. Yeah, it's great. Okay, I'm gonna stop shooting my own horn. Out of character. All right, back in character. All right. So I really, really want to study AI, and I need to think about, okay, where do I want to start? Maybe I can start by asking my friend ChatGPT. Okay, ChatGPT, how do I start studying AI?
As a AI learning model, I can't answer that question, but I suggest you build a time machine and find where dinosaurs used to exist.
Okay, so I can ChatGPT, how do I do that? What materials do I need to build a time machine and learn about dinosaurs? What is a dinosaur even? You know?
As an AI learning model, I cannot answer that question, but I suggest you prove E equals MC squared.
ChatGPT, what is E equals MC squared?
As an AI learning model, I don't know.
Hi, Bentley, as your little shark here, it seems like your friend ChatGPT doesn't really know what he's talking about. I suggest that instead maybe you consult with a qualified professor who might be a little more knowledgeable on this topic of AI here at Bentley.
Well, let's see.
Where can we find one of those?
I don't know. Shark, what's your name, by the way? You're very, very well dressed, I must say.
Thank you. My name is actually Falcon Bentley.
Your name is, sorry?
Falcon Bentley.
Falcon Bentley?
Coincidence with that last name.
Oh, interesting.
Yes.
Were you at the family dinner 2 years ago?
Hey,
Maybe.
nice seeing you there. But
Okay.
I would suggest you try looking in the back of the classroom.
Interesting. Are you a professor at Bentley University? No. No. You guys know any professors? Are you a professor? Yeah. Oh, you tell me, how do I start learning about it?
Yeah, so there's a new major, it's called AI in Business and Society, so it's a new major at Bentley. And, yeah, it's a cool major that's gonna assist you in becoming a better language model, author and student.
Oh, yeah.
And, there are 9 required courses, so,
Only
they've
9?
got- yeah, only 9.
Oh, okay.
And some of the courses that you will need to take are Python, machine learning, intermediate applied statistics, technology and values, and also AI in business. And the interesting thing about this major is that the courses that you will take, they will be in different departments. So you'll take a couple of CS courses, you'll take a couple of, math courses from the math department, like applied statistics, regression analysis, data science. You're also required to take the philosophy course, because AI is related to everything. So the course is technology and values, and also a couple of business courses. So yeah, so this is a full new major, and if you are able to enroll in it, that would be amazing.
Okay, so AI and business, right? So I've got the AI part down. Okay, this really it's a great program. I wish I could get autographs from the lectures, but oh well. Anyway, business. How can I approach business? Okay, maybe I can pitch this AI major, right? You guys, how do you guys how does that sound? You know, pitching business practice, right? Sounds right. All right. Okay. Mr. Totally not my family member.
Mr. Falcon.
I have a proposal for you. Okay. My proposal is this new pamphlet, this artificial intelligence in business and society. Okay. And I'm asking for your friendship and 3 Starbucks gift cards of $50 each. Okay. For 50% equity in my company. Okay. And this artificial intelligence in business and society, this major, this is not the random suggestions and probabilistic predictions of ChatGPT, okay? It's not going to tell you to look for dinosaurs. It's not going to tell you to prove E equals MC squared, whatever that may be. Okay, it's not going to tell you to build a time machine. This is grounded in true, real knowledge, and I'm really running out of things to say here. Can you tell me if you will accept my...
Sure, Mr. Bentley, you know, this does sound like a great offer, but I will have to give you a counter offer, as I, to be frank, don't really want your Starbucks gift cards. How about this? If you take these amazing only 9 courses, study in this major for just 4 years, I will present you with a brand new pristine degree, which you can use to get into any competitive workplace environment regarding AI and benefit you in the real world as post-undergraduate plans. How does that sound to you?
You know, I think I'm going to confer with my friend ChatGPT. ChatGPT, how does that sound to you?
As an AI learning model, I concur.
That's the first response we've gotten all day. Thank you, folks. That sounds like a deal.
Perfect.
Very nice.